All right, stats. Here we are for your notes video for January 25th, 2023. All right, we are learning remotely, which means you have plenty of time to read some of America's and really the world's greatest classics here. And the Goggins double. Can't hurt me. Never finished. Followed by, it's going to take you some time, but the Gulag Archipelago, there you go. And then for our young readers there, our folks, we're still learning. Green Eggs and Ham by Dr. Seuss. Yes, really the world's greatest sales book. Okay, so for our future salesmen, you guys know who you are, Green Eggs and Ham. So we're going to do page 4 and 5 here in your notes packet, chapter 13, binomial mean and standard deviation. So the mean, write this down, the mean, or you don't have to write it down, it's there. The mean is n times p, and the standard deviation, right, is n, the square root of n times p times 1 minus p, or you see some books say n times p times q, because q is in fact 1 minus p. All right, so if X is the number of hits you get in your first 100 at-bats this season and you're a 310 lifetime hitter, find the mean and the standard deviation, right? The mean is the expected value. So the mean is 100 times 0.310. That's 31. You expect to get 31 hits. The standard deviation is the square root of 100 times 0.31 times 0.69. All right, which is 4.62. You're going to round to 2 decimals. So again, what did I do over here? That's within one standard deviation. So like to catch outliers here, because a lot of players in Major League Baseball, they get off to really hot or really cold starts, and then people always say, they're going to play to the back of their baseball card, to their career averages. They're going to regress to the mean. So like this would be to catch outliers. So we would expect, if this player's a 310 lifetime hitter, if they start the first 25 to 30 games of the season hitting between, what is that, like 260, that's 3, that's 2, it's around like 210 to really 402. Again, this is out of 100 at-bats. It wouldn't be, shocking. Now let's look at the first 200 at-bats, so the first like 50 to 60 games of the season. If X is the mean number of hits you get in your first, again, the mean is still a 310 average, so it's still 310 times 262. Now the standard deviation, 6.54. So then if we do 62, again, you don't have to do, this wasn't what they were asking, but if you add and subtract that, so what we got, we're gonna have 4892 to 7508, and if you divide both of those by 200, on the low end here, it was in the 210s. Now we expect that player, if they got off to a really bad start, again, plus or minus 2 standard deviation catches outliers. So if this batter is hitting 240 after 200 bats, like something big time is going wrong, they can still be hitting 245, 250, and it's on the really low end of their production, but it's not out of ordinary. If they were hitting like 270 after 200 bats, it's like, it's not good, but it's not, oh man, this player now stinks, all the way up to, so that average that was like 402 on the really high end now is going to dip down to 375. See, if they got off to a really, really hot start, that would be expected to come back down. And then you got 500 at-bats this season. What's the mean and the standard deviation? So that's a standard deviation. Even though we're like more than doubling the at-bats, the standard deviation is not more than double. Okay, so now if we did that, if we did the mean, again, you need to pause this whenever, go ahead. I'm not trying to make an incredibly long video for you. Okay. So what is that? That's like 134.32. So like a really bad season, this is out of 500 bats, a really bad season for this player would be 268. So notice how it went from like 210 to 245 to 268. Even if they were on the really low performing end, it would be coming up. And a really exceptional season for this player would be like 353, right? So started off 402, then went to 375, and then went to 353. So if they got off to a really hot start, we would expect it to come down to earth. And if they got off to a really slow start, we'd expect it to eventually creep back up. So this player could hit like 283 for the year. It wouldn't be a good season, but it wouldn't be like, oh, this is an outlier season. We need to try to trade the player, or we're not going to resign said player. Okay, the mean is N times P. That's the expected value. Standard deviation is the square root of N times P times 1 minus P. Okay, this is really in the wrong section, but because 5 games is not really long enough to do what we're gonna do on Thursday. So it's just this wrong section. Oh wow, no big deal. So X is a win. You're gonna play in a 5-game tournament where you get a top 3 place if you win 4 or 5 games. Right? If you win 3 out of your first 4 games, you're gonna be playing in the 3rd place game. And if you win the first 4, obviously you're gonna be playing for first or second, which means you got a top 3 finish. So what's the probability you don't get a top 3 place? You don't get a trophy. So X is win, and we want to know the probability of winning 3 or fewer games. So that's 3, 2, 1, 0. That's 4 probabilities versus 1 minus the probability of 4 or more, and that's only 2 probabilities. So again, finding 2 probabilities is quicker. So find the probability that X is 4 and X is 5, which I've shown you there. The probability of winning is 0.9. Add those 2 together and subtract from 1. You know, if you have 25 of these tournaments, in 2 of these tournaments, you don't get a trophy. That's what we're saying there. All right, you guys have a pretty quick one here. You flip a coin. I like these questions here. You flip a coin 20 times. Let X be the number of heads. You count. Describe the values of X that should be counted as outliers. Explain your reasoning. So again, the mean is the expected value. You know, so I use expected value here. It's 10. Standard deviation is a square root of 20 times 0.5 times 0.5. Which is the square root of 5, which is 2.24. So again, outliers are outside of 2 of the mean plus or minus 2 standard deviations. So 10 plus or minus 2 standard deviations gives you the following. So again, the number of heads is a whole number. So any amount of heads 5 or less or 15 or more would be an outlier situation. So if you told me you flipped a coin 17 or 20 times and it came up heads 17 times, that would be an outlier. Again, not impossible. It would be an outlier situation. This is a good question here. You're a 74% free throw shooter. You're going to attempt 30 free throws during a given stretch. Would making 27 or more be an outlier performance? Explain. It should clearly be a question mark. Oops. Explain it 2 different ways. So we can do what we just handle it or in the same way that we just did. Expected value, the mean is 0.74 times 30, 22.2. You do expect to make 22.2 out of 30. Standard deviation is 2.40. Rounded down. That's important to know. So if I do the mean plus or minus 2 standard deviations, my upper bound is literally 27.0. Whoa. So 27 is technically in that upper bound. Because remember, I did round down, so it was actually like 27.04, I think. Right? Or 27.04. So technically, it's not outside. Again, we're looking at a high outlier. So but first, remember, outliers happen, in 2 different directions. You have a low outlier, 2.5% there, 2.5% there. So yeah, an outlier happens 5% of the time or less, but it's split evenly. 2.5% chance of a low outlier, 2.5% chance of a high outlier. So we're looking at the high outlier situation. So what's the probability of making 27 or more? Okay, so let's find the probability of 27, 28, 29, 30. So that's the probability of 27, 021. That's the probability of 28, 006. The probability of 29 is 001. And the probability of making all 30 is like essentially zero, right? It was 000 something. It's zero. If you add those up, so I know that that's less than 5%, but remember, and I told you outliers happen 5% of the time or less, but again, they're split evenly. So your performance would be here, strong, like an outlier on the good performance side would be a 2.5% chance. So it would be like right here. It would technically, it's still within 2 standard deviations. All right, so we wouldn't, like, it's barely not an outlier. If that was 0.023 or 0.024, then yes, it would be an outlier. Again, 2.5% chance low outlier, 2.5% chance high outlier. That gives you 5% chance of having an outlier. All right, you make a sale 30% of the time. You meet a potential customer. You're going to meet with 80 this upcoming week. You can realistically expect to make how many sales this week? So obviously 24 is the expected value. The mean and the standard deviation is 4.1. So it's the mean plus or minus 2 standard deviations. Okay. 16. So basically between 16 and 32. How about that? A whole number sales. So 16 would be a bad week for you. 32 would be a really good week. And those would all be realistic. Anything outside, anything 15 or less, an outlier. 33 or more, an outlier. All right, folks. This is Yak Math Videos. Telling you I will see you on Thursday, and we are signing out.